Hello everyone. Thanks for listening to learn more about the 2019 Brazosport ACS Crystal Growing Competition. Today we'll be giving some introductions on the presenters today, a background on crystals, learning more about the competition, and the resources to succeed in order to win great prizes this year. Today who will be presenting is myself, Dr. John O'Brien. I'm a chemist at Dow Chemical Company and the 2019 chair of Brazosport ACS section in Lake Jackson, Texas. Also presenting today is Dr. Ana Nunez, also a scientist at Dow Chemical who works in Freeport, Texas.
Hi, everyone.
The 2019 ACS Brazosport County Crystal Growing Competition is a county-wide competition for high school and junior high students to see who can grow the best quality crystal. And the main point of this is actually to learn more about the science of crystals and to win great prizes. ACS is actually providing free starter kits this year for the high school and junior high students and teachers. And this competition is actually launching in early February, and will go through April 1st, 2019. At this point, the crystals will be judged, and then the awardees will be announced for the competition this year. And with that, I hand over the presentation to Ana Nunez to learn more about crystals and their background.
Thank you, John. So you might be wondering what crystals are. Crystals, just like everything else that we can find in nature, is built of atoms. What is special about them is that they are solids that are arranged in a regular pattern of repeating units. So crystals are known for having particular symmetries. In nature, there are several examples of crystalline substances that exist in their natural state as crystals. So, for example, snowflakes, simple substances such as table salt or sodium chloride, and also gemstones such as diamonds are examples of crystals. So all of these are substances that are formed under different conditions, and there are different interactions between the atoms. There are also examples of synthetic crystals that can be made in the lab. So a couple of examples are cubic zirconia, which is used to make jewelry, or polymers such as plastic. So how are crystals studied? This is where crystallography is used. So crystallography comes from the Greek krystallos, that means ice or crystal, and graphene, which means to write. So crystallography is the branch of science that is used to study the structure and properties of crystals. So as a science, since 1901, crystallography or the use of crystallography has produced 29 Nobel Prizes, which is pretty amazing and more than any other scientific field. So it is readily used in applications such as mineralogy, chemistry, physics, math, biology, and material science. And it is a very powerful tool because crystallography helps a scientist understand every detail of what is going on. So for example, in an industrial process, to something that is happening inside of the body. So these are examples of how crystallography is used. So for this competition, we're going to be using aluminum potassium sulfate dodecahydrate, also known as alum. So alum is formed by an atom of potassium, an atom of aluminum, 2 sulfate groups, and 12 waters that are all arranged in a crystallographic plane. So this is the smallest repeating unit of alum. Alum has been used for a very long time. Its oldest known use dates back to ancient Egypt, where it was used to clarify water. Nowadays, it has many applications that range from medicinal, culinary purposes, and other industrial applications. So for example, it is used as a pickling agent and also to make deodorants. So this was chosen as a chemical that we're going to use. One of the reasons is that it makes really pretty crystals, and it's readily soluble in water. So the solubility in water is 14 grams in 100 milliliters, and this is at about room temperature. If you heat the water, you can dissolve a little bit more, so roughly 36 or 37 grams in 100 milliliters of water if you have heated the water to 50 degrees Celsius. So we want to start by mentioning safety. The material that we're using is relatively safe, but as any time that we're working in the lab, we want to exercise good laboratory practice, and we need to make sure that we're using some protective equipment to protect our skin, our eyes. So we recommend that some precautions are used. So we want to use gloves, lab coats, and goggles. So the overall competition happens in 2 stages, or the crystal growth happens in 2 stages. The first one, we're gonna grow a seed crystal. So the idea or the goal of the competition is to grow one big single crystal instead of a lot of small crystals. And so in order to do this, you need to exercise some patience. So again, the first step is to grow our seed crystal. So you need to make sure that you allow your crystal enough time to arrange in this particular crystalline pattern. The first step is to dissolve some alum in water. And one of the things that allows a good crystallization process is to have a very clean medium. So we're recommended to use distilled or deionized water. So we're going to heat this water at about 20 degrees above room temperature. And once we've done this, we're going to dissolve an amount of this alum salt to produce a supersaturated solution. And so a supersaturated solution pretty much is the state of a substance in which there is more solution that will, or more salt than will go into solution. And John is going to tell us more details about that in a minute. So we're gonna make our supersaturated solution, and then we're gonna pour this warm solution in a shallow dish and then slowly cool it down to room temperature. And this is gonna take a few days, and after that we should have a few crystals, and using a magnifier glass we're gonna pick the best crystals to then grow into our bigger single crystal. So the second stage then is to grow that seed crystal. In order to do this, we want to pick the seed crystal, and pretty much what we're doing is letting it sit in a solution of supersaturated solution. So in order to do this, we're going to take our seed crystal and tie it. So we have provided nylon string. You can use a fishing line too. And so we are going to tie that, and then using the sticks that are also provided in the kit, we're going to allow this seed crystal to be suspended in a small volume of supersaturated solution. You can use a petri dish, for example. And then you allow this to grow for a couple of days, and then again using some patience and making sure that you are recycling the solution to make sure that more atoms are allowed to stick to the surface of the crystal to grow a bigger single crystal. And with this, I hand it to John so he can tell you more about details on the supersaturated solution and some rules of the competition and prices.
Thanks so much for that great explanation, Anna. So as Anna explained, one of the main vehicles for growing the single crystal is actually producing a supersaturated solution. And there's a few different methods that we can actually do this. And two methods are actually within the kit. The first method is actually adding double the amount of salt that you normally put within room temperature. And for the case of alum, this is about 28 grams per 100 milliliters. So the idea at this point is to add this into the water and stir until you cannot get any more into solution, and then gently warm the solution even further until you start getting this more and more into solution. Once all the substance is in solution with heat, you then remove it from the heat and allow it to cool down to temperature. At this point, you have a supersaturated solution, and it is really normal to see some solid crystals at the bottom at this point. This solution is kind of the vehicle that you're going to be using to grow this great crystal, so make sure you take good care of the solution. Another method that you can do this is actually taking the water just as it is and heating it about 15 to 20 degrees above room temperature. At this point, you then slowly add the salt to this warm mixture until it's completely into solution. And then you keep on adding this slowly until you cannot add any more of the salt. At this point, this hot, saturated solution you remove from heat and then allow it to cool down. Again, at this point, you can use this to grow your crystal even further. The next phase within this is after you've already grown your seed crystal and started to gain some larger mass of your smaller seed crystal. The idea is to grow a very large single crystal that looks beautiful. And there's a couple different methods and ways that you can actually do this. And a couple different tips are actually within the kit and the instructions. So one thing is to carefully suspend the seed crystal from the stick into the supersaturated solution that we made. Another thing to keep in mind is to make sure that you cover the container that the crystal is growing in and make sure you keep out any dust. Another thing to keep in mind is make sure that you don't have any temperature fluctuations when growing the crystal. So you don't want to put it in a windowsill where the temperature is going to be changing on the time of day because of sunlight. One way that you can actually cover this is with plastic or aluminum foil, or another way you can do this is with filter paper so that the solution can slowly evaporate over time, making sure that your supersaturated solution is always saturated. At this point, you really want to keep an eye on your crystal and see how it's growing over time. And the really key with this is sometimes a really slow process in making sure that you're always having a supersaturated solution with the crystal. The one thing to keep in mind throughout this whole process, you may need to supersaturate your solution maybe on a daily basis, a couple times a week, or once a week in order to make sure that your crystal is growing larger over time. One thing that keep in mind is each time you saturate the solution is to make sure that it's at room temperature before you put the crystal back into solution. Another thing to keep in mind is to always make sure that your crystal is clean and looking good. And you can do that with a magnifying glass and maybe some tweezers to kind of make sure that everything's looking good over time. And the other thing is to do this and repeat it over several times throughout the whole competition. You have 2 months, so you have plenty of time to actually make something really nice. A couple of rules to keep in mind throughout this whole process is first, you're only allowed to use up to 100 grams of the alum in order to make your crystal. Each kit has about 500 grams, so you should be able to grow up to potentially 5 different crystals throughout this whole process. Another thing to keep in mind is that your crystal, when you submit it at the final judging, you need to make sure you record the total amount you used for the final crystal. That's how we're going to actually judge you on how well you did. In order to make sure that everyone has an equal amount of time, we're going to start this competition in early February and end on April 1st. For each classroom, only 2 crystals can be submitted. So as a team, make sure that you guys are picking the top 2 that will be judged. Each submission will receive a quality and an overall score, which I'll describe in just a minute. And again, at this point, all crystals need to be received no later than April 5th. The judging of this crystal will be based on 1, the size of the actual crystal, and how it looks. Some things about the quality of the crystal will be based on the match of the actual crystal type, the presence of any occlusions, if it has any broken edges, how well formed the faces are, and also the clarity. So if you take a look at the crystals on the right, the ones on the left are very clear, very big. These are great looking crystals. Whereas on the ones on the right are actually very opaque, have a lot of different edges. These are examples of crystals that have grown very fast and really not single crystal and had very poor growth. And lastly, after you submit the crystals, prizes will be announced and winners will be awarded. And this year we're awarding based on the junior high and high school students, and also if you make a very unique crystal, something out there that we didn't think of. And lastly, we'll be giving prizes to a teacher's best crystal. There's a lot of resources on the internet. Some of them are suggested within the pamphlet that were handed out. And there's also a lot of great resources at the U.S. Crystal Growing Competition and the Canadian Crystal Growing Competition. Feel free to look at those or any other resources to make sure that you're growing the best crystal possible. The context for this year for the crystal competition is myself and Yifan Dong. Please reach out and we'll be happy to help you out. And with that, thank you so much and have fun, guys.
Thank you.